Now up to this point, all of our equations have contained a single variable, and we've solved the equation to find that variable's value. Some equations contain two variables, and while we can't determine definitive values for both, we can solve the equation for one variable in the sense that we find out how to calculate it with respect to the other one. For example, in this equation we have the variables x and y. And we're going to solve this equation for y. So to do that we need to isolate the y term, and what we'll do is the opposite of our minus 4x on both sides. So we end up adding 4x over on the right and cancelling it out on the left. Now we can divide both sides by 2 in order to isolate y from its coefficient. And that gives us a definition of y with respect to x. So now that we have that definition, we can calculate the value of y for any given value of x. For example, when x is 1, then y is 3. When x is 2, then y is 5. When x is 3, then y is 7, and so on. And we can use these x and y value pairs as coordinates and plot them like this. And those plotted points form a line on which every possible pair of x and y values for the equation can be found, which is why we call these things linear equations.